Hey guys, today we're not doing anything new but reviewing everything, some of the trickier problems that you've come across. So what I want to do with this worksheet, this is the same worksheet you have for homework, and I just want to make sure you have a hint on how to start each of these. I wouldn't recommend writing it down, just try to think and follow along, okay? So just reading the instructions for the first one. We want to know where f of x has a max or min. So hopefully you know your goal on that one would be a first derivative sign chart. Okay, that's pretty straightforward. Second one, where is f of x increasing or decreasing? That's also a first derivative sign chart. Okay, but be careful about critical points. That's where your first derivative is 0 or undefined. But be warned, this original function has a place where x doesn't even exist. Remember, if x was 2, you'd have division by 0, and that represents a vertical asymptote. So there's actually no value at 2. You'll see a little bit more when you work through that one. All right, number 3, same, increasing. So you're going to do a first derivative sign chart. Okay, and also remember when you're dealing with E makes you happy because E is always positive. Positive, happy E. Okay, number 4, concave up. So you're looking for a second derivative sign chart. But don't forget, when you see natural logs or when you see square roots, bells and whistles should be going off in your head. When you have a natural log, you can't take the natural log of a negative number. So you should go immediately to your second derivative sign chart, go to 0, and say, nope, nothing to the left of that exists. Same thing with this. We're doing an increasing and decreasing first derivative sign chart. So figure out when will this be 0, which is -3. Okay, so go to -3 on my sign chart. You have to cross off either to the left or to the right of that. You don't want underneath the radical to be negative. Okay, so I have to cross off to the left this time. Okay, skipping to number 8. This is a very typical AP multiple choice type question. Okay, we want to know if the original function has these things at 2. Okay, well, does it have a horizontal tangent? That would be when the derivative is 0. Okay, but this is the derivative already. Okay, Roman numeral 2, is there a maximum? Well, that would be when this derivative is 0, but also this derivative would have to change from positive to negative. Okay, and third, is there a point of inflection? That's when the second derivative is 0 and changes signs. Okay, so you'd actually have to get the derivative of this for that one. There was an important one that I skipped. Number 5, I did not mean to skip that one. All right, so for number 5, treat A like a number. It's just a coefficient. And you're supposed to find that what A has to be so that there's an inflection point when x is 2. Well, you might not know right away how to do that, but if inflection point means the second derivative is 0 and changes signs. But we can start with this. So find the second derivative, set it equal to 0, and then let x equal 2. Okay, see if you can figure that out. I have all these problems worked out in the solutions on Canvas, so let me know if you need me to work them out in a video. Good luck. Bye.